a wider aspect. So now stormwater and its management. So I would like to give some highlight on the old theory. The stormwater system should be designed to move the rainwater as quickly as possible from the urban area. This was the old theory. But nowadays, with sustainable development, with new approach, with new technology, with new softwares, we are having a new theory like the stormwater system should be designed to capture the rainwater and delay the discharge for downstream area. See, this word is very important, the delay the discharge to the downstream area. Now when you are considering the rainfall which is going to happen in particular land, so now the natural system was like nala and it is going to connect to the river or something, some any other natural outfall available. But now what happened, there is a lot of development and the nala or some natural stream got shrinked. So we need to understand what is the capacity of that existing system and how we can regulate that flow and which will not affect the downstream area. That particular thing we need to consider. So this is the new approach we are adopting with new technology and with new softwares. So I would like to take a I would like to give some introduction to stormwater. Stormwater is nothing but the rain or melted snow that flows from some local properties, some local hilly terrain, and it comes to some natural streams or into the stream, and it connects to the stormwater drain, and it will go to the outfall. So the stormwater management we need to take into the consideration, because to avoid some kind of a flooding which is going to take place in the urbanized areas, to avoid some erosion of a soil, or to maintain the water quality better. So these are some objectives behind the stormwater management, and why they are very much needed, why they are why the design is very much important is to see that we are not going to affect our development, which is very much costly in the while building again, while developing again, if we got anything worse. So I would like to just introduce like why we need to manage the stormwater. Like what is the need of the stormwater management? So in the slide you can see that the first slide is of Mumbai region, where you can see that the whole track is flooded, and you cannot run your trains on the on that particular track, and people who are going to travel from some place to another place, they are going to be stuck on the stations only, and they cannot reach to their destination, and they cannot perform their activities like if they are going to work for school or any other reasons. So the second picture, if you can see, it is one of the airport picture, where you can see that the planes are standing because of the flooding. They cannot take off, and they cannot land also. So the people who are going to travel for international, the material or goods which is traveling for the international cities, it cannot go, and there will be a lot of issues with respect to the financial aspect. If it is there any essential products which is going to be delivered, it will get delayed. So these are some issues with lack of stormwater management. So the third picture, if you can see that there is a road construction, but there was a huge rainfall in the upstream region. So the bridge or the road, it got flooded, and you cannot travel from one place to another place. Now the fourth picture, if you can see, the complete road is going to be flooded in the rainy season. Especially if you can see this picture in Mumbai region or any Chennai region, that most of the cities are flooded in the rainy season. Now the fifth picture, you can see, this is the Chennai region, which is taken from the plain view, where you can see that the whole city, some part of that city got flooded due to the heavy rainfall. The last picture you can see, this is one of the typical picture you can see on your road also, that there will be water stagnation at some places, and you can see that the water is still standing there, and while you are driving, your speed get reduced, the visibility gets reduced, and there may be chances of accidents also. So for this reason, we need to manage the stormwater, and to avoid any future loss, we require the stormwater management. Now, the scope of stormwater design. Normally, in case of a road design, we call it as a drainage design. So, in the next slide, you will get to know that the term the drainage design. But stormwater design and drainage design go parallelly. So, what are the data required? So, normally we require survey in the form of topographical survey in the form of the existing systems, survey in the form of CCTV, survey in the form of what is the available unit there, and how the rainwater is capturing there, survey in terms of the development. So these are the survey types we required. Now the second thing we require is a rainfall value. How we are going to take a rainfall, how much rainfall is going to occur at that place, how critical uh, is rainfall value at that particular place. We require that rainfall value also. Moving to next part is the master planning. If we are constructing any smart city or something, we need a proper planning, that these places are going to be the schools, these places will be having a roads, these places will be having a open land, this place will be having a temple or something. This particular master planning we required in case of a stormwater management. Now the fourth data required is the outfall location and the constraint. So when I'm saying the outfall location and its constraints, so it means that if there is a natural outfall where we can connect the existing stormwater design, that particular level we required where we need to drop it. And constraint is regarding with the how much water we can discharge, how much water with particular quality we can discharge. That are the constraint which we need to take into consideration while designing the stormwater design. So constraints part will be explained detail in next slides. So when we are designing anything with specific region like Middle East, for NZ, for US, we need to study the codes and specifications. What specification that country adopt, means they use it for it. Then the grading and development, how the site is going to be graded, how the levels are going to be checked, how the levels are going to be um managed, what are how the cutting and filling is going to be balanced, what are the site constraints, if there may be, like some land is not going to be acquired, this land may be going to be acquired in future. So this particular constraint we need to take into consideration while designing the stormwater part, because when the external catchment is there, we need to take care of that also, so that it will not affect our drainage design and our area. Normally, when we consider a stormwater and its element, we have the bridges. Bridges are divided into major bridges and minor bridges. Then we have the culverts. Culverts like pipe culvert, we can say, we can use the box culvert. Then the drainage elements, like we have the stormwater networks. The stormwater network can be in the form of pit and pipe, in the form of V-shaped channel, in the form of open channel, in the form of swells. There are various stormwater networks we use in our designs. Then we have the aqueducts, and then we have the SUDs. These two features we will cover in detail in the next slide. So when we consider a drainage system, so we have the four methods, like we collect something, we have its convey we have that water to be collected with different methods. Like if you can see in this slide, we have the curb drainage, we have the gully drainage, we have the slot drains, we have the open channel drains, we have the uh, what we can say, we have the V channel drains. From this particular drains, we are going to collect the water which is into the which is going to come from the developed area, from the road surface, from any paved surface. We are going to collect that water uh, on the road. Like whenever you are seeing the normal roads, you have the pipe opening available. From that particular opening, the water will be collected. Now the second part is conveyance. The water which is collected from the gullies, from the openings, the that water is going to be conveyed with the help of underground system. That underground system is consist of pipe network. The pipe network is again divided with different manholes for the cleaning purpose, for the inspection purpose, and the stormwater pipe may range from its diameter, like starting from 150 mm, 300 mm, and it can go up to large as much as possible, with how much and it will depend upon how much flow it is going to be contributed from the collection feature. Then the next part will come as a storage and attenuation part. So when we are taking the stormwater from any urbanized area or any developed area, we will take that into the storage and attenuation part. The storage and attenuation part consists of lot of features, like we can have a pond, we can have a swells, we can have a bioswells, we can have some kind of a tank system available with geomembrane or something, and we can store that water to reduce the time of discharge to the outfall location. And with the outfall location, which is the last, which is going to be in the stream or in the nala or in the river or something, there we have the head walls with outfall location, with outfall controls. So this part will also be covered in detail. Now, as I discuss, what are the input parameters we required is rainfall values. Then, when we get the rainfall values, we require the runoff coefficient or PMP classification also. So now, what is mean by runoff coefficient? Now, if you can see any road, like you seen yesterday with smart motorway presentation, there is a road with paved shoulder, there is a road with hard shoulder, there is a road with verge, there is a road with the hard strip. So all the characteristics are different for the rainfall, for the runoff coefficient. For like when you see the paved part, so all the water is going to be collected at the gully location, or at the any curb inlet or something, with full its full capacity. But when there is a verge, or then there is a swell or something, then some part of a water is going to be percolated. Then the third part is a return period. So a return period is very important when we are considering the stormwater designing. Return periods are normally like 1 in 1 return period, 1 in 10 return period, 1 in 30-year return period, 1 in 100-year return period. So normally when we are designing the bridge, we check the return period for 1 in 100. But whenever we are designing the road drainage system, we are checking it for 1 in 10 year, 1 in 30 year, 1 in 50 year, etc., etc. So the next part is a time of concentration. Time of concentration is very important term when we are calculating the flow which is going to come at the inlet location. So there are various formulas for calculating the time of concentration. So that part will also be covered in next slides. And the last part is a climate change. Nowadays we can see that lot of things are changing with respect to nature. We are observing lot of storms, we are observing a lot of hurricanes or something. So the climate is going to change. That particular climate change value we need to take into our consideration while designing the stormwater designing, so that our system will be foolproof with that particular storm event, or in any different or difficult cases. So the design procedure what we adopt is, the first thing when we are doing the stormwater designing is, the we mark the catchment area. So you can see the pictures that I have one picture, like where we can see that the residential area, there are some roads, there are some other highway, or you can see that some plots are there. So that particular area we need to mark it, and we need to assign that particular area to our catch basin or to our inlets. So this particular area needs to be attached to the catch basin with proper runoff coefficient, which I explained earlier. So the second thing is setting up the design criteria, like return period, time of concentration, and climate change, which I explained earlier. So whenever we are building any model in any software, we need to set up some design criteria: how much velocity we are going to allow, how much cover we are going to allow for pipe, how much constraints we are having at the outfall location. So all this parameter we need to set first, so that we can run our model properly. Then the part will come as a designing and analysis. When I'm saying the designing and analysis, designing means how much pipe size we required, how much flow is going to come. And when we are considering the analysis part, so analysis is something for how much return period we are checking that particular thing, like 1 in 10 year, 1 in 30 year rainfall event, 1 in 50 year rainfall event, for how much time we are going to check that. So this part will come into the designing analysis. Now when we are finalizing our designing, we need to take care of the constraints which are available at the outfall location. Normally in the developed countries, they allow 10 liter per second as a outfall constraint, and some particular water quality should be there. You need to treat that water before discharging into natural stream. That particular constraint we need to take care before starting our optimization process. Now optimization process is nothing but, we need to be very much concerned about the cost economics also, because the highway projects, the infrastructure projects are very much costly, and we cannot give the designs with oversize. So we need to be properly optimize our designs, so that the client will be happy, the authorities will be happy. And the last part will come as a drawing production. So we need to produce our drawings with respect to that. The site people will understand our levels, understand our designs, and they can properly execute the drawings which we are doing, the design and drawings which we are doing in the office. So uh, when we are designing particularly about the road drainage, we need to check the aquaplaning, spread check, or flow width. This all terms are the same only, but aquaplaning check we call it in Australia New Zealand region. Spread check we consider in Indian cases, and flow width and something we can consider in UK and Middle East standards. And the networking part. So the first figure you can see that there is a car passing which is passing through the water. But when the gullies and the conveyance system is introduced, the water is going to be collected smoothly at the edge of the curb, and we can have our car passing very much easily. Then the second and the third slide, if you can see that when we are considering the aquaplaning check, we need to consider that for how much speed the vehicle is going to travel, like 80 kilometer per second, 50 kilometer per second per hour, 70 kilometer per hour, 90 kilometer per hour. According to that, we need to take care of our aquaplaning checks, so that there will not be any skid of the vehicle, there will not be any accidents, there will not be any visibility issues to the drivers. Because ultimate goal is to have, if we are planning any road or something, we should we should design our roads such that the driver or any passenger who is going to travel from that particular road, he should be safe. That is our first motto. Then the last two slides, if you can see that there is a road, and we are going to have some inlets in the form of gullies, or inlet in the form of curb and channel, and that can be taken into the networking. So there are two type of networks normally we adopt, like one is a parallel drainage system and one is a central drainage system. It is nothing but central drainage system is collecting the water at a central location, and here we can minimize some kind of a pipe, and we can minimize some kind of a cost with respect to the project. But in the parallel drainage system, it has its own advantages, and central drainage system has its own advantages and disadvantages. Now I would like to hand over to Radhika for SURS and the next part.
Thanks, Omkar. As Omkar talked about storage systems in the beginning, we have something called SUDS, or they are called sustainable drainage systems. So basically, they are the feature which will help us to control the water flow into the water bodies. So in many countries, like in the UK or in Australia or in US, we cannot release whatever water is falling on the surface directly into the natural water course, like river or stream. So whatever flow rate the whatever water was flowing in when the conditions were brownfield. Omkar talked about what is brownfield and greenfield, like without development and with development. So before any development, we don't have any concrete surface, so water can directly flow, it can percolate into the ground. And therefore the flow is less into the water streams. But once the area gets developed, or there is concretization happening, the water cannot percolate any further into the ground, and most of it will flow on the surface, and it will flow to the water course. So um the impact on the water course is, there may be a rise in the water level, which may flood the areas which are nearby, or there may be some impact if there is like oil spills happening on the road, so the it may contaminate the river water. So because of that, we have a restriction on how much water can go into the river surface. So SUDS, or sustainable drainage systems, allow the water to flow. It stores it, or it decreases the flow rate, or improves the water quality. So as you can see from these various snapshots, these are different kind of sustainable drainage systems. One you can see of a natural pond that is uh, constructed. Then there are certain tanks which you can construct, or the one which you can see below is a swale. Next slide, please. So the function of a sustainable drainage system is what we call as attenuation. Now, attenuation is basically to limit the flow in either the pipe system or in some storage system like the SUDS. Okay, so here I'll take a minute to explain what is climate change. So as you can see, the temperatures are increasing, or you can see the effects of global warming. And when you are designing any project, whether it's a road or a bridge or railway, 50 years or 20 years ahead of the time, the climate will be different than what it is today. So what usually is assumed that the rainfall is going to increase in future. So whatever rains we are having now may it will be more. And because of this impact of climate change, we consider that there is an increase in the rainfall. Usually this factor is taken by 20% or 40%, depending on what is your design period, like if it is 40 years or 100 years. Okay, so the aim of our attenuation is whatever additional, so for example, today we are having 1 liter per second of flow. that is happening from our site. But after 50 years, this flow will become, let's say, 10 liters per second. So this flow has increased an additional by 9 liters per second. So we cannot so what the standards in UK or in US say that you cannot release that 9 liters per second directly. You need to store it for an adequate amount of time and keep the rate of flow as same 1 liter per second. So that additional 9 liters per second will get stored in our storage system, which we call as attenuation. So the factors that influence the size of the storage is, one is how much rate of inflow we are having, and second is how much outflow we require. Okay. And this curve you must have seen in reservoir routing, or for example some when you are doing irrigation engineering. So basically it is a similar curve that we follow, where whatever is above the outflow line is as a stored volume. Next slide, Omkar. So, talking about methods of attenuation, we have different types. Like we have ponds, which you can see below um, in the picture. Pond is nothing but a huge storage depression where we are continuing to store the water. And the another thing that a pond can do, like Omkar talked about before as well, we can have some kind of quality improvement in the water. So in pond we have settling happening, which will help the water to also purify a bit, like all the suspended solids will settle. We have swales. Swale is nothing but like a grassed channel through which the water can flow. So some part of the water percolates into the ground and it gets treated, while some and whatever remaining goes on to flow to the outfall. We have filter strips, again similar to swales. Even bioretention swales, like I talked about, there may be some plants planted at the bottom, which will help to trap the sediments and improve the quality of the water. And we have a detention basin, which is similar to a pond, but we have sedimentation happening because the water flows are very slow in the detention basin, and the water keeps in a suspended way. So the solids which are not dissolved will slowly settle down. And these features you can build in any area which is adjacent to the road. For example, a swale can be flowing, it can be located parallel to the roadside. Wherever you have some green area, you can plant the swale and it can flow towards the outfall. Or a pond can be a natural element that you can use, or you can create a depression in wherever area there is space, and you can store the water. Next slide, please. Another important feature which works in conjunction with the story flow with the suds system is flow control. So water is getting stored in, let's say, a pond. Okay, and you need to release that water slowly to the outfall. So in the outfall pipe we have something called flow control. You must have heard of flow controls like weirs in hydraulics. Okay, similar way we have these flow controls. So at the outfall or the outermost pipe, or maybe the outfall pipe from the pond, we can have these flow controls installed. You can have a single flow control like penstock or a gate, or we have vortex flow control. So the image that you can see on the lower right side corner is a vortex flow control, which has an automated gate to, so whenever water builds up, this gate will close, and it will allow only a particular quantity of water to flow outside. And this vortex is installed inside a manhole. You can have more than one flow control at a time, like in combination. For example, orifice plate. So the top right image is an orifice plate. It's basically a plate with a small opening of whichever size you want or how much water you want to outlet. On the left side you can see what is a weir. This is very common. It like a V notch or a veer is something that is used in open channels. Like if you have a ditch or you have a surface water channel, you can use it to control the flows. So what the major function of these flow control is, it will stop the water inside whichever storage device you are having, whether it is a pipe or whether it is a uh, pond or whether it is a detention basin. Next slide, please. Now, I'll just cover a little bit to give you a flare of the different drainage systems which we design around the world. Like, let me start with a little shedding some light on the UK drainage systems. So, for example, I have the image in front of me, which maybe you must have seen yesterday in when you're the smart motorways presentation, is a typical cross section for highway. So we have the road, which is the two lanes, or maybe it may be multiple lanes. We have something called a shoulder, which is adjacent to the road system. Then we have something called the verge. So verge is basically a grassed area which is running parallel to our road, and where majorly our pipes are located. So in UK drainage system, when we talk about where our pipes should be located, it may be either in the central reserve, which you can see from this image, or it may be the verge. So when you have a super elevated section, like when the water is flowing towards the center, the pipes in the center will collect the water, okay, with the help of some gullies or any kind of collection system. And when you talk in the verge, so when you have a balanced carriageway, like when water is flowing on both the sides, you will have the pipes placed in the verge, and they will collect the water and convey it. And on the right hand side, you can also see a slope. So along with the paved area, we may also have some grassed areas which is coming from the slopes, or from any cutting that is it depends on how the road is built. So the paved is the our paved area is the road surfaces. The grassed areas will be the verges or the slopes. Next slide. So in UK drainage, usually the units that we use is our SI units, like meters, meter kilometer, in that way. And the standards that we are using are the DMRB standards, which are the link is being given, and it covers a lot of things, like how what is the time of concentration you need to use, what is the rainfall data you need to use, what kind of uh, limiting rates for the water we have. Okay, so I will just quickly cover what Omkar has also talked before, but in reference to UK drainage. So when I start off with designing drainage for the UK region, what design inputs I will need? So first thing I need is how much rainfall is going to happen in that area. So for that, we have two methods by which they have come up. So different regions have different rainfall. So in India, for example, you have a lot of rainfall happening. That information you can find in maps which are being prepared. Similarly, for the UK, we have maps where in the flood estimation handbook or in FEH method, which gives you like average rainfall happening over different areas in the UK. Or we can have another method called FSR rainfall. So basically, it gives me how much rainfall is going to take place in that particular region. Second is the time of concentration. So time of concentration is basically the time that is required for the water to fall on the on the most distant point from on the watershed up to the outfall. So we may take something, for example, like 5 minutes for the water to come right up to the outfall. And as we discussed before, we need how much impermeable area or permeable area we have. So depending on how our capital is put together, concretized islands are all part of impermeable area. And permeable area, as we have discussed in that previous image, we have verge, we have cut slopes, or any grassed islands will go as a part of a permeable area. Next slide, please. Now the system that is used, so basically in the UK mostly we are using gullies. So gullies are just like you must have seen on Indian roads as well. You have a grated cover on the top and a small pot below it, and water will flow and fall into that gully. We also use a lot of surface channels like V-shaped channels, open channels, which can directly collect the flow. This is also called over the edge drainage. The water directly falls into the channel and can flow towards the outfall. Curb drains, so the road has a curb into which the drains are installed. And we have slot drains. Okay, so these are very commonly used collection features in UK drainage. The next is the conveyance. Conveyance, as you know, we will do it through pipes. So usually pipes are, for example, they start it at 150 diameter and can go like 600 diameter or 900 diameters. Storage, as I discussed before, we can do two types of attenuation. One is you can store in pipes. You can install the flow control device in the manhole, and you can have like oversized pipe, like pipes in the range of 600 diameter, 900 diameter, and you can store water in that. Or you can have offline attenuation, or like SUD features, which like pond tanks or swales, which can store the water. Outfall, at the outfall we need to limit the discharges to greenfield rates, like whatever, like I talked about this before. If the existing rate is 1 liter per second, when my development is happening, after the development also I need to maintain that 1 liter per second, so remaining water goes into the storage. So usually we apply 20 to 40% climate change as applicable to the design period. Like for example, if I'm designing at 30 years, it will be 20%. At 100 years, I will apply 40%. That means if my flow, if the rainfall is, let's say, 20 per hour today, in 20 years I will apply 20% to that rainfall, which will increase it. So the commonly used softwares in UK drainage, like which we use for modeling, is micro drainage, which does the pipe modeling, and Civil 3D is used as an interface between micro drainage and whatever. For example, catchment area marking we need to do, or we need to see what kind of contours are there. So for that, we are using Civil 3D. Next slide, Omkar. So this is just a screenshot for the software for micro drainage. Before Excel sheets are also used for designing. You must have heard of EPNet as a software, which is a freeware that is available. So this is slightly advanced version. It is by Innovize, and so we have everything that we can enter into this. Like the manhole number, what is the pipe length, what is the invert elevation on the upstream side, downstream invert elevation, what is the diameter of the pipe, what is the manhole diameter of the pipe. If you see the table below, it will give you what is the velocity that will take place in the pipe once you are assigning the areas. So this is just to show you how the drainage network is modeled in a software. So all the data that I discussed before, like the pipe length or the manhole, I have input into this micro drainage. Okay, next slide. And when I run this software, it gives me how the different pipes are performing with respect to the water that is coming in. For example, you can see that there's a pipe 2.001 which is flooding, means the water is exceeding the capacity of the pipe. So this software gives me how much, whether my system is able to take the flows or not. So if, for example, this pipe is flooding, what I need to do is I need to increase the size of the pipe in order that the water will be able to take up. um, Next slide. So this is a typical layout of the pipe system that we discussed. What you can see is you can see a road alignment. Okay, these tadpoles show cutting or filling how the road is. The lines that you can see are the pipes that I have laid. Okay, and you can see that slowly the water is going towards the outfall, so there is a pond located. So whatever water I'm collecting from the road, it is going into the pond first, and then whatever storage is happening in the pond, it is going to the outfall. So this is the most simplest representation of how our drainage system is designed: a pipe, then a storage device, and then we have the outfall. Next slide. The next one that I would just like to give you a brief is on the US drainage. So, like UK drainage, we have DMRB standards. In the US drainage, we have DOT standards, or Department of Transportation standards, for every different state that is there. For example, if it is New York, it has a different New York Department of Transport standards, or if it is Nevada, Nevada Department of Transportation standards. So each the standards are pretty much the same, but there may be a few small clauses which are different for each standard. uh, and each state has its own design methodology. Usually the software, like for example micro drainage, is used in the UK very commonly. We have in the US, we are using various softwares like Inroads, Geopack, or you must have heard Stormcat, or XPSWMM. So basically, all these softwares have a similar uh, core function, or the engine is the only thing is that the interface is different for each of these softwares, and the way we input data and the way we view results are different for different softwares. The units usually that are used are in foot pounds in the US, which is more common there. Few projects also use meters, but mostly foot pound system is more often used. Next slide. So this is a layout of the Geopack software, which I have designed. The previous screenshot was for micro drainage. So here the pipe sizes vary between 12 inches. So now I'm talking in inches and feet. So we have, it all goes from 12 inches up to any 24-inch, 48 inches, and so on. We can have circular pipes, or we can have box pipes. We can have arched pipes, which are commonly used. Here also we can use storage features like ponds or swales for storing the water. Basically, the methodology or the crux remains the same, whether it is UK region, US region, Australia region, or Middle East region. Only thing is, you will find that the terminology that is being used in different regions will be slightly different, and the standards that are being used are different. Next slide. So this is a screenshot from Geopack software. So what I have in front of me is, you must have heard of long sections and cross sections. So what I showed you before, that the road is called a cross section, where you can see the different road elements, and this is a long section of the pipe drainage system. So you can see what all is displayed, like what is the invert elevation, what is the slope of the pipe, the name of the pipe chambers. um, you can also see the HGL line in green color on the top, like the water level to which it is rising. From that, we can see whether the water level is the aim is the the water level in the pipe or the manhole should not go above the ground, which is the red line in the image. So we are aiming to design our pipe sizes such that the water level, that green line which you can see, remains below the ground surface. So that is the main aim when we are designing stormwater systems. And also you can see the chainage below. Um, yeah. Another thing that I would like to cover in very short is BIM, and how it relates to drainage. So every discipline nowadays has a BIM, or building information management, component to it. uh, Basically it is more like how much data you can input into the system, how much more information you can have. So the as related to drainage, what we do is, when we are producing any drawing or any model, we have to ensure that the layers or the levels, like for example civil 3D we are using as our uh, software, or any other software that we use, whether it is microstation or in geopack, we need to ensure that the elements are in BIM compliant layers. And the aim is that we deliver a clash free model. Clash free in the sense, I have laid my pipes in or my pipes on my road, but apart from these stormwater pipes, there are also other utilities which are there on the road. For example, there may be telecommunication lines, there may be wastewater lines, there could be some lighting technology in that system. So my pipes should not be in the same location where, for example, there is a telecommunication wire which is going, or there is a high pressure gas line which is in that location. So for that, this BIM is very useful. We prepare 3D models in our network, and there is something called a interdisciplinary check process, wherein people from different disciplines, like I talked about, maybe the telecommunications people from the roads team, people from drainage team, they all sit together and they view this model. In various softwares are available, like Navisworks is there, Revitzo is there, and there are many other softwares which you may find, where you can view this 3D model and you can check if your pipes are clashing with other utilities. And if there is such a clash, the usually it is like, since a drainage is usually designed in the end, all other components are put before. Either if we can modify our drainage system, we will try to divert that pipe, or we will try to um, relocate that pipe in some other location uh, nearby, so that we can avoid the clash. Next slide. So these are few images which I have taken to see if the clash is available. So the first image that you can see is the typical road system, and with the road we have different other system. Like you can see a um, um, sign on the top, so there will be some foundation for that sign in the below the ground, or you in orange color which you can see there, that is a technology line which is running parallel to my road. uh, the second image that you can see is the blue color or cyan colored, is showing my pipe system. So what I can see is this blue colored pipe is going is tying into the road drainage, and there is a manhole which is there. So this manhole, so there is some corridors defined. For example, light yellow color may be a technology like lighting technology, or some wires that are running. So if my chamber is running into this light yellow colored ground, I can view that there is a clash, and I can try to relocate that chamber behind into that green colored pavement which is my verge. So this is just a example of how we can see that model in 3D, and we can avoid any clashes. And the last picture is a 3D model below the ground, where I am able to see all my pipes. And we also have white colored, that is my for example, that technology ducting that I talked about. And one of the pipes is, if you can see, it is almost inside that technology ducting. So my if I have noticed this clash, I will try to remove this pipe and slightly outside this technology ducting. So this is just an example that how we check clashes in while designing the model. Next slide, please. Yes, I think from here, Omkar can take up Australia and New Zealand regions. Over
Yeah.
to you.
Thank you, Radhika. Thank you. So basically, we are aiming to cover the different regions, the different standards we are using. So now, when we are talked about UK drainage, then US drainage, so we are moving towards Australia and New Zealand region. So the basic concept with respect to the different region is we need to give some overview to you, like how they are planning their stormwater designing, what features they are using, and what are the different types they are using, which are different than other ours. So for the ANZ drainage insight, Australia New Zealand is a very big region, and it observes a lot of different storms. Like when you are in Sydney, when you are in Melbourne, when you are seeing Perth, so all the regions have the different rainfall events. So some part will have a small rainfall, some part will have a drastic rainfall, the time duration of a rainfall. So all this parameter we need to take into the consideration while doing our drainage designing. So the first part we need to take, like the rainfall values, what we need to consider. So in the Australia New Zealand region, there are two methods like ARI and AEP. These are the written periods they are considering, which are having their own formats. So this particular data you can download it from their Australian meteorological website, and you can use directly into your software, which comes in the Excel format, and you can use that in your any of the softwares. Now the aqua planning, when I'm seeing the aqua planning, the Australia New Zealand region is basically more emphasized, more focused on the collection features. When I'm seeing the collection features, like they are very much concerned about the collections which is happening from the ground to the conveyance system, which is in the form of pipe. So the aquaplaning check needs to be done properly, because it will affect the vehicle speed limit, or there will be any hazards will be possible if we are not maintaining the aquaplaning check. So normally their range is a 4 mm water depth, which they allow on a road surface. If you are getting more than 4 mm water depth, then straight away they reject the design. They tell us that you need to design the road properly, so that it will fit into the aquaplaning checks. So for the Australia New Zealand region, there are some standards which are available, but Austroads is the main standard, which is very much common in Australia New Zealand region. But when they are divided with New South Wales region, the Melbourne region, the Brisbane region, they have their own standards, like Queensland manual, NSW manuals. The Melbourne has a different manual. So we need to take into the consideration of that particular standards when we are designing the region specific jobs. So normally the software we use in the Australia New Zealand region is a 12D, which is a main basic software, which is a string based software, which road people, any grading person can use, and the same files can be shared on the same software, and the drainage person can also work on that particular software, and he can produce the outputs. There are some different softwares like music, the drains software, which they use for a small catchment areas and for checking some quick checks. So here, along with 12D, they use some microstation platform also to create the drawings which are compatible with the beam standards. They use some Autodesk Civil 3D software also to produce some beam outputs and other things. Here also they have the same approach of creating the ponds, creating the swells for the search features, and they are also having some constraints for outfall location, for outfall discharge also. So I am having one picture of a rail project which I did in Melbourne region. So here you can see that there is a one roundabout, and there is a level crossing of a rail. So now for the future, for the development, they are going to change the this particular level crossing. So there are very different options are tried first, like this rail can go above the road, rail can go below the road, then road can go below the rail, and road can go above the rail. So these 4 to 5 options, they study how much land we need to acquire, they study it for it, they study then how the drainage going to be affected in the vicinity, and how much impact we are going to create about uh, other places which are there in the vicinity. That all factor they are going to consider. The cost factor is the main factor, but these particular factors are also going to be considered, and one particular option is going to be finalized for the next review, and up to the detailed designing procedure. So here if you can see, this option is having road over the rail. So rail crossing is going to be maintained as it is, and the road development which we are going to do, for that we are having a pipe network which we are going to lay here. If you can see in the blue color, there we are going to have a detention pond, and we are going to connect to the existing system which is available in the vicinity. For that particular existing network, which may be in the form of gully, it may be in the form of pipe, we need to go back to the available data there with survey or something, or rail map or something, like how much diameter is available there, how much flow we can discharge, and that particular calculation we need to do, and we need to apply some control features to safe discharge of the stormwater from into the outfall location. So this is the 12D software we use into designing of Australia drainage system. Here you can see there are a lot of tabs available, and the right hand side corner you can see the perspective image of a surface which is available. So here you can see that there is a road which is available. You can see that there are some manholes available. The road is sloping, sorry, the hill is sloping towards the road, which have the contribution from that particular area, which is non-paved area. So we need to take care of that particular stormwater. We need to design the stormwater in a such a way that we will take care of the road surface water, and we can discharge at some outfall location, which you can see in the plan view. So in the plan view, we are giving a big pond here to store the water, and we can release that particular water into the natural stream. The below that you can see one L section which is available, where you can see that the pipe which is having the invert level, you can see 29, 30 here. These are the invert levels. The above you can see the length, the above you can see the slope, which is maintained as a 0.5 normally, 0.5%. And we are going to discharge at a outfall location, where you can see some small ditch type ground, where we can have a safe discharge of the stormwater. So this software we use in Australia, New Zealand region, which is their requirement in the form of drawing check, design checks, drawing output. So all the things we can do into this particular software. Now coming back to Middle East region. So Middle East region is again very tricky with respect to, you can see that Middle East is also starting from some countries like Abu Dhabi also, sorry, Dubai also, to Saudi also. So they all have some different rainfall values, some different standards. So different developments are going to be there. So normally we use IDF curves there for having a rainfall values. And Middle East job we normally do in Dubai region, Saudi region. So we use different codes and standards for those locations. So Abu Dhabi standards are already set there. We have the standard drawings available. Then the Syria manual is there. So Syria manual is very much focused with respect to the stormwater designing. So you can go online and you can search about these manuals, and you can study that also. Now the software we used in the Middle East region is for the stormwater design is Sewergem, or sometimes we use Civil Storm also. So it is very much specific with client in which format they want the outputs. So for the in Middle East region also, they are going with a beam compliant model. So for the beam compiled models, we are using Civil 3D as a software. So Civil 3D, we work on a data shortcut basis. So data shortcut is nothing but everyone is going to share their models. Like the road person is going to share his model, the stormwater person is going to share his model, the water supply, sewerage, the electrical one, they all are going to share their model, and they are combined in the Civil 3D format. And one can see the, or any BIM manager can see the clashes, and he can get back to us to optimize our designs, and change some locations, change if there are any constraint or something, or clashing is he notices. Then about the flash floods. So in the Middle East region, we normally observe that there is no rainfall which is available, like with respect to the Indian condition. They have very shorter duration rainfall, but sometimes there are some flash floods. So you can see in the news, like there was a rainfall for only 2 hours, only 15 minutes, but lot of highways, lot of roads are submerged due to that particular rainfall. So we need to take care of that particular flash flood events also when we are designing into the Middle East region. So I would like to share one project which is having a township development in the Middle East, where it was a completely greenfield project. The land is totally available for us to have our design trials. So we have tried a lot of options, like taking the road from here, taking the road from this direction, how much cutting filling balance we can do, so that we can minimize our cost, because cost is also a very much concern in this particular region. So accordingly, once they finalize their road layout, you can see that the number of culverts we have introduced. The culverts are introduced based on the wadis. Wadis are nothing but the natural streams which called it in the Middle East region. So that particular natural streams we need to take care with giving the proper size of the culverts in the form of pipe culverts, in the form of box culverts. So the sizing of that culvert, the score protection, the head wall, the requirement of a riprap, we all need to design that particular thing, so that the design is the design will get approved. So the second picture you can see, this is one typical cross section of a road, and you can see that there is one pond we have given, and the pond, when get oversized, it will go into the culvert, and it will discharge at the outfall location. This is some kind of a control we are a control measure we are adopting in Middle East region, so that when there will be a flash flood, it will not affect our uh, road embankment, and it will not affect the road. It will not the road is not get flooded, or the road is not get destructed. So this kind of a method we are using there to store the water for some time, and we are creating some delay in the stormwater. So these are some insight in the Middle East Sewergem and input parameters we use in the Sewergem. The first picture we can see that this is from QGIS, where we have created one terrain. And if you can see, there are small lines which are available, and you can see that they are the streams which we have generated from the survey. Now, when you are considering the whole region, it is not possible to have a topographical survey. So we are majorly depend upon lidar survey. So the lidar files will be received in some format, and we can take that format in our QGIS or ArcGIS format, and we can delineate the catchments, how much catchment is contributing to that particular stream, and how much how much that stream is going to make a flow, so that the downstream end we can plan proper culverts, proper size of the culverts, and so that the flooding get avoided. So the second tab, you can see the storm data we required. So in the sewer gem there are lot of things we can input in the sewer gem, like there are methods like time depth, time intensity, user defined idf. Normally we use the idf table in Middle East region, but there are different tabs are available, like hydro file if you have, the idf table, curve equation if you have, rain file if you have. Now if you are working on UK region, earlier Radhika explained, we have the flood studies report that also can be introduced in the sewer gem. If you have the Australian rainfall standard, then also that can be important, and you can work on that particular software. Now besides that, you can see the sewer gem output in the form of one plan layout I have shown here, and you can see the color coding also. Now the green color, you can see the catchment areas which are assigned to the upstream nodes of the channel. Here normally we go with the swells. They are in the form of bioswells also, or in the form of natural vegetation also. So the swells will have the contribution at the upstream node, and accordingly we check for the velocity concern. Now if you can see, there are three colors you can see, like one is green, one is blue, and the second one is a red color. So we have the ranges of velocity, like below 2 meter per second, below 5 meter per second, and above that. So normally when we are going above 5 meter per second, we need to make sure that the channel or the conveyance system should be properly reinforced in the form of grouted riprap or in the form of concrete, so that there will not be erosion of a soil, there will not be erosion of any surrounding soil or surrounding embankment also. So we need to take care of that. So accordingly we normally design with respect to maximum limit we are going to set here. So for that we need to set up our design constraint such that the velocity criteria, the cover criteria we are already going to set. The last picture you can see the below is the profile or the long section we can check here. So the blue color, if you can see, this is the water depth which is going to raise at outfall location. So here also we check for a different return period, like 1 in 10 year, 1 in 50 year, 1 in 100 year also. So some part if we are checking for 1 in 100 year, it is a requirement from Middle East region, like we should not flood the system for 1 in 100 year. So you can surcharge that. So that means that you can touch your ground level, but you cannot the water can touch to the ground level, but it cannot flood on the road surface. So these are some criteria we need to check, and for that we can check some L sections. This L section we can take into the engineering profile, and we can give it to drafter for final production in the form of PDF. So this output is consist of the chain edges, the elevation, the slope, the length, all the parameters. What is the flow contribution, what is the size we have given, what is the invert level we are going to give that particular channel or for that pipe. So this software will help us in to take our design to the next level, or to tackle some issues which are present in between, and we can solve that issues very quickly. So the basic idea behind all the regions we are going to cover is we are going to give some insight about Indian drainage system, what we are adopting, how we are doing our designs, and where we are and where we need to go. So about the Indian drainage design, like India also very interesting with respect to the stormwater design part, because when you can see India has a snowfall also, India has a um, different regions like Rajasthan also, where we will not get that much particular rainfall, where what we can get into the regions like Himachal Pradesh or Manali or any northeast region. We have rainfall event in Mumbai which is different. We have the rainfall event in Nagpur which is different. So it is very interesting to design the projects in Indian region also. So normally when we consider about the authorities for the road, we have the NHI, the State Highway Department, so PWD is there. So if we are going for a township projects or any smart motorway, smart city projects, we have the SIDCO or any national housing board is there. So they have their own standards, they have some their specifications that we need to follow. Now the data, we require the data in the form of rainfall. Normally we can get some IDF curve which are available, because in Indian also there are a lot of rain gauge station available in India at every major rivers. So they calculate the rainfall. Maybe there are some airport stations which are available, so they have their own rainfall measurement systems, and the whole data is calibrated and whole data we can use properly. We require the controls also, because Indian condition, we have very dense forest, somewhere we cannot go. So at that location we can use some lidar survey, or survey in the form of topographical survey. We can do that, and we can use that particular contour file for our understanding and finalizing our layout. Now with respect to constraint, so when we are considering the constraint, we have constraint regarding with the outfall location also, because our rivers, our ponds, our natural outfalls, they all are now get polluted, and we cannot discharge directly into that particular stream. So this constraint also we need to take care while designing the Indian drainage system. The Indian drainage system, when we are talking about the road, we have the IRC code available, we have the SP42, IRC5 as a major codes which are available for the drainage designing. Then we have the CPHO manual, then we have the CWC manual available. The CWC manual is a very good manual. You can go on the site and you can only search for a CWC manual. You will get to know how we are good in particular designing. Then there is a one good site which is launched by our ISRO and our meteorological department, which we call as a Bhuvan. You can go on that particular site and you can see all the catchment delineation, all the streams, and you can mark the catchment, you can judge the area, and you can calculate the flow. Here you can see one particular picture where I purposefully kept this some different with some different color coding, where you can see some different catchment with some different streams. So all the streams are going to be contributed at this blue color, and we need to consider all the catchments with their properties. Somewhere you can see that there is a dam available, somewhere you can see that there is some check dams are available. So all things we need to take care while designing, if while designing the bridge or while designing the culvert at this particular location. So there are two figures you can see here. One is a Indian picture and one is a hydrograph. You can see that Indian picture, this is a CWC exercise, and you can see this picture on their website also. So the Indian region is separated in 22 regions, where you can see 1A, 1B, 1C according to the major rivers. Like we have the Krishna River, we have the Bias River, we have the different major rivers like Godavari, Narmada, Tapi. So accordingly, they have demarcated the whole catchment, and CWC manual has its flood estimation report available, and there are some different formulas available. So that particular formula you can take and you can design your flow for a bigger catchment. With respect to the regions where you are doing your project. So here you can see the particular hydrograph we need to take care when the catchment area is big. So normally we do a synthetic unit hydrograph for 1 mm depth, and there are some input parameters required, and we check for how much critical time, what is the maximum flow is going to occur at that particular bridge location, for at that culvert location, and we need to design our system accordingly. So uh, with that, I would like to take overview of one of the airport projects we are doing. So when we are considering the airports, so there are some different requirements which we have, like we have the runway drainage we need to give. So runway drainage are like open channel drains at specified interval. Then you can see that there are some car parking, flight parking areas, we call it as a apron. So apron will have the oil spillage and something, so that particular spillage we need to take care. We cannot directly discharge into the natural stream. We need to have the oil separators, and we need to take care into the outfall location. Then we have the terminal building, the underdeveloped area, the future area. We need to take care all the things, and we need to discharge at some different location. Here you can see that all the water is taken into the W1 side, W2 side, C1 side, E1 side, the NE side differently because of the topographical conditions. So all the slope which is diverting into the W1 side, we are taken at a W1 side, we have inserted one pond here, and we are taking into the natural stream. So when we are considering some other outfalls like W2, C1, E2, NE, so all the system will have the pond first. We are regulating our flow, then we are discharging into the natural stream. So these are the common practices we adopt in Indian conditions. So there is a lot of things we can talk about the every region. So stormwater part is a very big when we are considering the design with respect to the smaller catchment and with respect to the bigger catchment also. So with this, I would like to conclude from our end that um, we almost tried to cover each and every region in specified time. And if you have any questions, we are ready for some time, and you can ask us. So before concluding, I would like to just say that when you are studying in your bachelor, when you are studying in your MTech, stormwater is a very small chapter you studied. But when you see in the practical or in the field, stormwater drainage requires a proper knowledge, proper management, so that your projects, your infrastructural projects are going to be sustained for longer duration, and you will get attracted to that particular projects. So with this, I would like to thank you very much for patient hearing. Thank you everyone who has attended, and thank you, Zeal. Radhika, yeah.
Yeah, I'd just like to thank all the participants, and thank you for listening, and hope this session was informative for all of you. And yeah, thanks to Zeal College for giving us this opportunity. Thank you.
Thank you, Ms. Radhika and Omkar Joshi. Thanks for sharing knowledgeable insights on stormwater design, global concepts, and design. Some key topics which were discussed today were based on data required for stormwater design, drainage design, input parameters for design procedure, drainage design of road drainage such as parallel drainage, central drainage system, flow attenuation, flow controls, DMRB standards, collection, conveyance, storage, outfall systems. We also discussed softwares for micro drainage input and result analysis. Ms. Radhika also gave glimpse on US drainage, DOT standards, software such as Inside Road, Geopack, Stormcad, representation drainage layout, then clash check using building information modeling. I would like to thank Mr. Omkar Joshi for sharing Australian New Zealand region drainage with analysis of 12D model results, key aspects of Middle East drainage with analysis of Severgram result, glimpse on Indian drainage design such as Indian design and project constraints, CWC manual, IRC codes and airport project overview. I'd like to thank you all for attending the session and I'll hope that this session greatly benefited to all attendees and helped in updation of knowledge on emerging trends in transportation engineering. I request all to attend afternoon session at 2:30 p.m. sharp. Link for feedback will be shared via emails and I'll request all to attend regularly for the next sessions. Thank you.